Okay, so this is our lovely Cartesian plane. I know you all know the Cartesian plane well, but I want to make sure that you guys know of your quadrants. Okay, so let's speak about quadrants. So the quadrants are these 4 blocks or spaces in the Cartesian plane. We start numbering at the top right. And if you look at the top right, that's usually what we use when we are drawing graphs. And I say that because that is where your positive x values and your positive y values are. So whatever coordinate that's going to be here is going to be a positive x value and a positive y value, which is what this bracket means. Okay, so we start off with the positive and positive, and then we number anti-clockwise. So we go from the top right to your top left. Okay, and that's where quadrant 2 is. Now in quadrant 2, your y values are still positive because you're above the axis, but your x values are now negative. Can we see that? So in this quadrant, all the coordinates will have a negative x value with a positive y value. And then we move down. Remember, we're moving anti-clockwise. We move down. That's where quadrant 3 is. And in quadrant 3, both your x and y values are negative. Okay. So coordinates in that quadrant will both be negative. And the last quadrant, which is the bottom right, is quadrant 4, where your x values are positive, but your y values are negative. Okay, speaking of quadrants and grade 10, you guys, next year, whoever decides to continue on with math, which is most of you, I hope, wink, wink, you guys will be dealing with sine and cos and tan of triangles, and you're going to need to know these quadrants pretty well. Okay, that's a major hint from me. So we're going to practice a little bit here. If my pen could work, that would be very lovely. But if it doesn't work, we continue. We move, ne? Life can't wait on the pen that doesn't work, that decides to misbehave here. All right, so it says plot 4 points. Firstly, I'm going to plot 4 points. Now, unfortunately, with this, I'm the only one who can plot these points, so you guys are just going to have to watch me do it. First, we have P, just to remind ourselves of plotting points. You have your X and then your Y value. So point P, your X value would be a negative 2, and your Y is 5. So that would be my point over there. And I name it, okay? Then I have a point Q, which is over here, negative 2 with negative 2. And then I have point R, which is at 4 and negative 2, so over there. And then I have point S, which is at 4 and 5. Okay, so now name the quadrants for each of these points. So I'm going to write them here. P, Q, R, and S. Let's start off with P. In which quadrant is point P? In which quadrant is point P? Let's hear, guys. Is anybody home? In which quadrant is point P? This is point P over here. We just spoke about the quadrants and how to number them. So let's hear some responses in the chat, please. Point P, which quadrant? Did you guys forget the quadrants? Can you guys hear me? Is anybody still awake? There we go, quadrants. There we go. Sorry, I wasn't getting the chats. And now I just got 100 chats. So give me time to catch up. People say they are tired, guys. I'm only reading the stuff now. Stress increases. Aibo. Otlale loves me. Aibo. Aibo, Aibo, Aibo. Meat and braise. And there are my answers. Quadrant 2. Literally, the chat wasn't moving, guys. So this whole time I thought I was alone. And Alice even said, ma'am, like, are you okay? She's losing it, guys. Yes, P is in quadrant 2. Sorry, guys. Sorry. I'll make sure to keep scrolling to make sure this chat is moving. Great. And then point Q. Point Q is in which quadrant, my lovelies? Quadrant 3, yes. What about point R? Point R. That's in quadrant 4, indeed. And lastly, point S. Point S. It's not 5, it's quadrant 1. Lovely. So you guys know where the quadrants are and everything. I'm going to do this thing one last time quickly because I know you guys got this and you know what's going on. Okay. -4 and 5. I've been told that's point A. B is at -2 and -3. And the last one is at 0 and 2. Before I even join these, nope, I just realized I didn't answer a question. Guys, something is wrong with me. Something is wrong with me. I am joining these dots so that you can answer the last question for me. What type of shape is PQRS? Let's hear in the chat. What type of shape do we have here? Square. Are we all sticking with square? Slindy's like, no, I'm sticking with rectangle. Oh, okay. So we're not gonna guess, obviously, right? Let me count the blocks. 1, 2, 3, 4, 5, 6 going that way. And 1, 2, 3, 4, 5, 6, 7. That was so close, guys. This is actually a rectangle. Because if it was a square, all of them would have to be 6 or 7 each. So this is indeed a rectangle. All right. Now I go back to this. And let's hope my brain is back to where it's supposed to be. Okay, what type of shape do you guys think this is? You guys should know it. Just based off of the points that there are 3 vertices. It's a triangle. So we've already answered the last question. Great. And then they say, in which quadrant does point B lie? So only point B this time. Point B is in quadrant. Thank you, Marlene. 3. Lovely, lovely. Okay. Yeah, you guys know this too well. So let's talk about definitions. I'm going to go back to that guy. Actually, no, let's do this guy quickly. Okay. So we have A, B, C, D, 4 points here. Okay, we're just going to answer these questions quickly and then write down the coordinates at the end. So for which point does y equals -8? For which point does y equals -8? That will be point A. Nice, Alice. I expected more responses. Now I'm scared of asking for more responses because just now it's my own chat that's not working. I have trust issues. For which point does x equal -6? That will be point B. Okay, remember, we don't look at the letters, we look at the dots. I know it's confusing sometimes, but the dots are what we look at. Okay, so it's actually B that's on -6 because it's over there. For which point does y equals -5? That will be point D. For which point is x 0? For which point is x 0? Dum, dum, dum. Interesting responses here. None. C. None. D. That will be point D. Okay, we'll speak about y at 0 just now. For which point is y equals to 0? That will be point C. Okay, let's write down the coordinates of these points here. And now that we've answered, I can zoom in. Okay, give me the coordinates of A, please. Now, if you don't write them with my brackets and semicolon, I'm not going to take your answer. Because bad habits that you learn while doing your homework are bad habits that you're going to carry through the test. And if I was your teacher, I would take away marks. So I don't want to do that. A is 3 with negative 8. Great. Let's look at B. Where's B? Over there. Remember, look at the dot, not the letter. B, negative 6 and 8. Let's see. Negative 6 is indeed with 8. C, 0 and negative 5, negative 6 and 0. There's a lot going on. Let's hear, guys. Let's reach a consensus about the coordinates of C. Negative 5 and 0. It is indeed negative 5 and 0. And finally, point D. This time it's 0 and negative 5. Okay. Now, we said we would speak about why the coordinates are 0. Now, if you look at C and D, let's look at C. So C definitely moved horizontally, right? It's not in the middle of the x-axis. So we know that the x-coordinate is not 0 because it moved to the left 5 times. But it didn't move vertically. You see that it's still technically on the 0 place for y. So that's why it's on the x-axis. That's where that 0 comes from. Whereas with D, it's the other way around. It moved vertically, it moved down, but it hasn't moved horizontally at all. It's still straight in the middle of the x-axis. So that's what makes the x-coordinate 0. All right. Now let's speak about what we came here to speak about, transformations. So we're going to speak about 4 different types of transformations. And a transformation is the rule that's going to describe a change in position, orientation, or the size of a shape. Okay. So for this section, we're going to look at the 4 different types of transformations. And the first one is a translation, which is actually just sliding the shape over a distance. Okay, so if we look here, I could put a point there and say I have moved B over there. So then I would have to say, then I moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 times to the right, and 1, 2, 3, 4 times down. That is a translation. All I did was move it. And this would be called B with a little line over there. What does that little line stand for? We've spoken about it before. I'm not sure if you guys will remember what it's called. B prime. Nice, Zanande. So then I would call that B prime. Now we're going to speak about why we call it B prime. Yeah, we're going to get there. Okay, so this is a translation. I've just taken a point and I've moved it anywhere along my 4 quadrants. Are we with me? So that's a translation. So this does not mean you only move it horizontally or you only move it vertically. You can move it both. Okay, just remember that. Secondly, we have a reflection, which is a flip. Okay, so we can either reflect something on the y-axis or on your x-axis. Okay, and what's important to know about reflections is the same distance that it was over the axis, it will be on the other side. This is what I mean. Okay, we have point A here, and we know it is 1, 2, 3 units or spaces, okay, from the y-axis. The coordinates will not be the same. There's only one thing that will change, but we'll talk about that. Okay, that means if I'm going to reflect it on my y-axis, which is like a mirror, it will also be 1, 2, 3. So it will be over there, and this is A prime. Okay, it's easy to see with a single point, but I know with a whole shape, it looks a bit different. But as long as you understand the concept with a single point, then it should be fine with the shape. All right, the third one is your rotation, which is turns over a certain point. Now, I can't show you a turn with a single coordinate, so I'm just going to show you what they mean in the definition here. They said around a certain point. If I have a triangle here that I'm calling ABC, and I'm going to rotate it around the B point. That means my B point stays where it is, okay? But I could move A there and C there. Are we with me? So your one point that is the focus of the rotation will stay where it is, but the whole shape turns around. Do you see why I can't show you with a single coordinate? It doesn't make sense. It doesn't make sense, but you guys get it. Okay, and the last one is enlargement or reduction, which is an increase or decrease in size. And what does that remind you of? One of the latest concepts that we did in geometry just before revision, enlargement or reduction, no, increasing or decreasing in size. What does that remind you of? Similarity. Nice, huh? It's similarity because they're not the same size. Okay, but speaking of what Maureen has brought up here, translations, reflections, and rotations will all be congruent shapes. Are we with me? So it is the same shape that you are just moving. Okay, so those three are congruent, but enlargement and reductions are similar because you are changing the size of the shape. All right. So this is just visual representations of what I said. Same shape, it's facing the same side, it's the same size, but you're just moving it up or down, left or right. All right, that's translation. Reflection, do you see what I meant? It's a bit different for a point. For a point, it looks like you just moved the whole shape that way. But this properly shows you what's happening. It's actually a flipping. So the one that was closest will remain closest. The one that was furthest will remain furthest. You have literally flipped the shape. You haven't moved it. Do you see the difference between a translation and a reflection? Because if I just took this and put it there, that's just a translation. Yes, it's a mirror image. Okay, so if I have a right angle triangle facing that way, and I reflect it, it's going to face that way. All right. So it's a bit better when you see a picture about what I am talking about. The next one is your rotation. Okay, it doesn't always rotate all the way around, but we'll speak about angles and all of that when we get to it. And of course, enlargement and reductions, which is what we have over here. It's the same shape, and the sides will always be in proportion. And speaking of sides that are in proportion, there's always an enlargement or reduction scale. Okay, and this directly relates to similarity because I'm going to make another example here. A, B, C, D, E, F. Let's say these shapes are similar. Okay, that means AB over DE is equal to BC over EF. If you missed these lessons, the videos are available, which is equal to AC over DF. Now, the number you're going to get when you do this calculation, okay, or when you divide the sides, that will equal your scale. Okay, because if I say AB over DE and my answer is 2, that means that this shape is exactly twice the size. I mean, ABC is twice the size of DEF. That's what the scale is. So once you prove that the shape is similar, you can find your scale based off of the proportionate sides. Does that make sense? And that also affects what? What else does that affect about shapes? Let's see if you guys can think that far. What else will the scale thing affect about the shape? The shapes together. It will affect the perimeter and area. The angles will remain the same, believe it or not. Remember, they still add up to 180. So nothing's going to happen. But it will affect your perimeter and area. What I mean is, if the sides are twice those ones, then your perimeter will be twice. Doesn't that make sense? Instead of adding 4 plus 4 plus 4, you're adding 8 plus 8 plus 8. That means your perimeter is also doubled. But with the area, if it's twice, then the area, when you do area, your unit is usually something squared. So it'll be the scale squared. Isn't that interesting? So instead of the area you have, it will be 4 times the area because you're squaring. Yeah, you know what? We'll do it when we get there. For now, I want us to start with translations. Okay, we are getting started with translations. And I'm going to start off with my own example because I want you guys to do the ones that are on here right now. Now, I asked you guys why it's important for us to use Z and Z prime, or A and A prime and whatever. Imagine I did this, and then after F, I went G, H. Would you guys know which one relates to the first one? Would you know which one is a translation of A? Would it have been possible? No. Okay, so that's why I have to write A prime, because otherwise, if these are all random letters, how will I know which one is a reflection of which one? I wouldn't know, right? In the same way, or similarly, when you are reflecting or rotating or translating shapes, I expect you to use this notation. Okay? A prime, B prime. Otherwise, I can't confirm if you have reflected it properly, for instance. So please. Now, we're going to do general rules of translating points. So I'm going to keep it to points for now, because we're technically not yet supposed to be doing translations, but I know you guys, so I put this here because I knew it would be done. So if I have, firstly, let's coordinates. Let's find coordinates. Please tell me the coordinates of Z and the coordinates of Z prime. Let's start with Z. Can I have the coordinates for Z, please? The coordinates for Z. -2 and 6. Let's see. Yes. And Z prime. Is 3 and 6. Okay, now my arrow, which shows that this has been translated or transformed to that. So for your general rule, you're going to say, I'm going to start at x, y, which is my original coordinates, and you're going to tell me how you moved x and y. Now, before we do that, let's talk about the Cartesian plane. If I move to the right on my x-axis, is that plus or minus? Am I adding or am I subtracting? If I move to the right on my Cartesian plane, let me draw it there rather. I'm adding. And if I move to the left, that means then I am subtracting. Great. Y-axis, if I move down, what is happening? Am I adding or subtracting? Subtracting. And if I go up, I am adding. Great. Now let's look at Z. Okay. I've moved it, and I've moved it to the right. So would that be a plus or minus? That would be a plus. How many times did I move it to the right? 5 times, 5 times, 5 times, so it's x plus 5. And what about my y coordinate? Has it moved at all? No, it hasn't. So I can just leave it as is. Okay, so basically this says start with the original x and move 5 times to the right. All right. Why do we need to do this? Because reality is, as we spoke about, we're not going to be moving a single point. We're going to be moving whole shapes. So can you imagine if you had like a pentagon that you were moving? You want to move these things correctly. So you check with a single point what the rule is, plus 5 to the right. And then you take every individual point and you plus 5. You get what the point of a general rule is. Because if you miss that point or that coordinate with one space, it is no longer a translation. You have now changed the whole entire shape. You have now made it. Do you get what I mean? So you get the rule using one point, and then you move the rest of them accordingly. Okay, so we're going to do these general rules for A up until F. Okay, let's start off with finding general coordinates, A and A prime. I don't know why they have to be so far apart. I'm obviously very extra today. Can I have the coordinates for A, please? 1, 2. Where is it? There. 1, 2. Coordinates of A prime. 4, 6, 5. Yes. Great. So I'm going from XY to X. Let's start with X. Is it plus or minus? It is plus. And how many times did it move? 1, 2, 3, 4. It is indeed 5. And my Y plus or minus? My Y plus or minus? It is plus. It went up. How many times? 3 times. And that's my translation. Okay. Now, a little trick, if you're not sure if you have counted correctly, is to use the coordinates. You take whichever one is the bigger coordinate and you minus the other one. This is what I mean, okay? So A prime had the bigger x value, which is 6, and you minus the smaller one, and that's 5 times, and it did indeed move 5 times. Does it make sense, guys? And for this one as well, 5 minus 2, and it did indeed move 3 times. Okay, makes sense? Great, let's move on to B and B prime. I'm seeing things over here. I just freaked myself out. Let's see, coordinates of B. Where's B? There. -2, 3. That would be correct. And B prime. Negative 6 and 6. Let's talk about the transformation, or the translation rather. X plus or minus, minus, and Alice says minus 4. Let's see. 1, 2, 3, 4. Y plus or minus, plus 1, 2, 3, indeed 3. I know these are hard to see, but this is the B prime. Okay. So we must first identify those maybe. Okay. For C, the yellow one is C, and the blue one will be C prime. Let me write it here. C prime with a little color coordination so that we don't get confused. Great. What are the coordinates of C? Okay, it seems Alice and Zanande agree. What does everybody else say? There's 20 other people here. Would it be plus because the x-axis is increasing, but in the negative? In the negative. What do you mean? But remember, when you are in the negative side for integers, right? When you are on the negative side, the value might be increasing, like the digit, but actually, the higher the digit, the less the number. Okay. So think about it as like owing a person. All right? It's lower and lower and lower as it goes. So negative 10 would be a smaller number than negative 2. Negative 2 would be greater than the negative 10. Does that make sense? You're welcome. Okay, let's look at C. Negative 5 with negative 2. Okay, and then C prime. The other way around, negative 2 with negative 5. Okay, let's move these guys. I'm already writing plus. X, okay, how did X move? Positive or negative, and how much? Positive or negative, and how much for X? Zananda says negative. Remember, we're moving to the right, guys. We're on the negative side, but we're still moving to the right. So what does that mean? If you're on the x-axis, we're moving from the yellow to the blue. From yellow to blue. That is a plus. Great. And how many times did it move? It moved 3 times. 1, 2, 3. Okay. And then the y, is it a plus or a minus? Is it a plus or a minus for y? That would be a minus, and let's check how much we moved. It is a 1, 2, and a 3. Great. Let's go for D and D prime. D prime. Okay, coordinates for D, please. That would be our yellow coordinates. Coordinates for D. Whoop, there's a lot going on. Let's see the yellow coordinates, which is this one over here. And that is 5 and -1. Well done, Leachilwe. And what about D prime? D prime. Come, guys, where did all my participants go? Oh, that's the ones in under had, yes. But where did everyone else go? 2 and -5. Let's come back to the party. Okay, let's talk about our translation. X, did it move left or right? And is that a plus or minus? Actually, don't answer the left or right. Is that a positive or a negative for X? A negative. There we go. Because we moved from yellow to the left. And as soon as we're moving left, we are minusing, we're decreasing. Okay. So it's X minus how many times? 3, 1, 2, and 3. Wonderful. Let's go with Y. Did we move positive or negative with Y? We did move negative. And how many times? 1, 2, 3, and 4. Great. Let's move on. E and E prime. Coordinates for E, please. The original one is always the yellow coordinate. Where's E? The yellow coordinate is the original one. So it is 0, -4. As we spoke about, it didn't move anywhere sideways. So your X coordinates is 0 and your Y, it moved down -4 times, which means my coordinate for E prime, which also didn't move anywhere sideways, will be 0 and 1. Let's do our translation. Everyone who's here and not participating, come, guys. X, where did X move and how many times did X move? Let's start with that. X didn't move, so I'm just going to leave it as X and Y, plus or minus. Plus, and how many times? See, 1, 2, 3, 4, 5. It is indeed 5 times. Ah, Senyani is here. Okay, Senyani, it's fine. You can watch the video. And finally, F and F prime. Let's go with coordinates for F, please. 3, 0, says Alice and Leachile. And what about F prime? -6 and 0. That would be correct. X, Y. Okay, let's talk about X movement. Plus or minus? That will be, there we go, Alice has it for us, negative, and we move 9 times. 6 plus 3 is 9, and my Y didn't move, so it's just a Y. Here we go for screenshots, and for the first time in a long time, can I have a thumbs up, thumbs down on all of these concepts? Yay, at least I'm getting thumbs up. I know you guys are here and listening. Okay, I have one more activity for us, and then we can call it a day. Woo! And it's filled with instructions. Draw triangle ABC. So we know it's a triangle with the following coordinates. Let me start off with that. A, -4 and 5. Alice, why do you sound shocked? B is -6 and 3. And C is -2 and 3. Alice, did I shock you, my dear? It won't be that bad. There were too many words. Guys, math is filled with words. You guys must get used to that. There we go. Draw the image of triangle ABC, which will be notated in the following way. Do you see how you notate it then, guys? So the image or the translation will have the prime after every letter. So triangle ABC will be moved, and that new translation is called triangle A prime, B prime, C prime. Okay. If it is translated using the rule, oh, now they gave us a rule. They gave us a rule. And we have to move all of these points. Great. You can either go and move your dots everywhere, but I am choosing to use my coordinates. So then point A prime will be -4 plus 3 and 5 minus 7, which is what? What's -4 plus 3? -4 plus 3. That is indeed -1. And 5 minus 7 will give me -2. So A prime has the following coordinates. Okay. A lot happened in the chat. I don't know what happened there. Okay. Point B prime will be -6 plus 3 and 3 minus 7. What's -6 plus 3? -6 plus 3, excuse me. That will give us a -3, and 3 minus 7, -4. So that's B prime. And the last coordinate, C prime, will be -2 plus 3 and 3 minus 7 again. Okay, -2 plus 3, that is 1. 3 minus 7, we've established, is -4. So let us draw A prime, B prime, C prime, now that we have it. Okay, so -1, -2, that's the first one there. -3, -4, that's over there. And 1 with -4 is all the way over there. So if you trust yourself with counting and you want to take those points and count all of them, that's fine. Personally, I prefer this method because I know 100% I have translated this properly. Okay, and then this new one, I realized I didn't even draw the correct. Here we go. So this one will be A prime, B prime, and C prime. Okay. DEF, this time they're telling us what the corners are, has the following vertex. 4, 2, 4, 2, yes, 4, 2, yes, 2, 0, and 6, 0. It looks like the same triangle to me, just at a different place. there, and there, and there. But this time they're calling it a DEF for some reason. Great. Determine the translation in the following form. If, so there are two conditions here, right? So we need to find the general rule if DEF is the image of ABC. So if this was moved there, we need to find the general rule. Okay, and then again, if this was moved there. So we have two things we're working out here. Okay, where am I going to draw this? Let's start with D, F, and A, B, C. So A, we had was -4 and 5. And this moved to D, which is 4 and 2. Great, let's hear. We went from X, okay, let me actually, yes, we went from XY. Tell me what the X translation was. Plus or minus? Is X plus or minus? Anybody still there? It's plus, right? It moved from A to there. So that's plus. And how many times did we move? 8. Thank you. Great. And my Y, is it plus or minus? My Y is minus. Let's see. 1, 2, and 3. Okay. So just to be safe, I'm going to do B as well. You're actually supposed to do all of them. I'm not supposed to be doing shortcuts. -6, 3. And E is 2, 0. Okay. X, Y. And we can see from -6 to 2, that will be 1, 2, 3, 4, 5, 6, 7, 8. X plus 8. And your Y? 1, 2, 3, -3. So this is our general rule for that translation. Then let's find the general rule for A prime, B prime, C prime being moved. So we went from -1 to -1, -2 to D, which is 4, 2. Great. Start with X. Is that a plus or a minus? Is it a plus or a minus for A prime? Plus, and how many times did we move? We went from there to there. 5. Let's see. 1, 2, 3, 4, and that is indeed 5. Great. And what about Y? Plus or minus? That would be plus, and let's check. We moved 1, 2, 3, 4 times. I'm not going to do the rest. I did promise you, you're going to leave early to do the quiz.